Alright, so for this one here, you want to find the seventh term. Okay, so you got to first of all figure out how do you find like the first term, the second term, the third term, the fourth term, and so forth. Okay, so in this combination, if we were to expand this the long way, so if we, for instance, did, let's see, to the 14, so forth like this, okay, all the way down to the 14th, right, because we have the power of 14. We'd have 3x here, and so forth. So if I times this 3x here, and this here, and this here, and this here, all the way down here, we're going to get something where it's x to the power of 14, and the 3's are going to multiply each other. So it's going to 3 to the power of 14, something like this. And if we want to get the second term, it's going to be 1x reduced, so x to the 13. And of course there's going to be a number out here, but we don't really care about this currently. Okay? So if we keep going, plus dot dot dot, this is our first term, this is our second term, our third term is going to be x to the power of 12, our fourth term is going to be x to the power of 11, our fifth term is going to be x to the power of 10, our sixth term is going to be x to the power of 9, and finally our seventh term should be something with x to the power of 8. So that's the first thing you have to somehow manage, is figure out what term you're going to be looking for. Okay, and you could use Pascal's triangle as well, but it's easy enough to go here. You're going to have x to the 14, x to the 13, x to the 12, and so forth. Okay, so we are looking for the term with x to the power of 18. Or, pardon me, x to the power of 8. So if that's the case, we set up our three brackets. In here we have 3x. In here we have minus 4 over x squared. We have our 14 here because that's our n, and now we have missing something here, here, and here. And this is where we have to figure out and use a little bit of trickery. So inside here you're going to have x to the power of something for sure. We won't worry about the 3 for now. And that's going to be multiplied by something over x squared. And both of these are going to have powers on them. And somehow we may have to make sure that whatever power goes here, and when you apply it on this x and when you apply it on this x squared, it equals to something like x to the power of 8. And we know that these two powers have to add up to 14, because that's what our n is, right? Remember, this is our n up here. So if that's the case, well, how do we start? I would start guessing. So I would guess 7 and 7 and start right in the middle. Okay, so if this is the case, if I go on the side here, I have x to the 7 times 1 over, well, this 7 comes in here, times it by the 2, x to the 14. And as you can see, we're going to end up getting 1 over x to the power of 7, because x will cancel there, oops, 14, and you'll have x to the power of 7. So this is way off. This is nowhere near x to the power of 8. That's what we're looking for. And so slowly we have to adjust these numbers here and here and slowly figure out, well, what could happen? Well, we need this x to be bigger, and we need this x to have less. So this number here, 7, has to increase. So now, if you want to increase it by 1, you can, but we need to increase it significantly. So what if I put x to the 11 here and x to the 3 here? All right. If I do that, I'll have x to the 11 times 1 over x squared to the 3. Okay. And I have x11 times 1 over x to the 6, and this gives me x to the 5. So once again, this is still not high enough. So 11 and 3, I need this to be even bigger. So if I put 12 here and I put 2 here, we're going to have x to the 12 and x to the 4. And now we can do a little bit of mental algebra. 12 and 4 will cancel, and we'll have our x to the 8th term. So with a little bit of guess and fix up, I figured out that we should have 12 here, so my 3x. We have 2 here. That's minus 4 over x squared. They add up to 14 together. That means this will be my 14 and finally my 2 because this one has to be the same as here.